Good morning, everyone. Welcome back to our EIGRP lab series. This is lab 2, basic EIGRP configuration. In this lab, we will be configuring EIGRP AS100, establish neighbor adjacency, verify topology and routing table, verify EIGRP parameters. But before we jump into that, let's bring the topology. Let's zoom out a bit. So in the previous lab, we completed the initial configuration of all 7 routers. We have R1, R2, R3, R4, R5, R6, R7, all 7 routers. We configured the host names, physical interfaces, IP address for all the interfaces, and we also configured the loopback interface. We then verified connectivity between directly connected routes. These are directly connected routes, right? So at this point, each router has routes only to its directly connected directly connected networks and its own loopback interface. The routers have not yet learned any of the remote networks in the topology. So for example, uh, let's take R1, right? So R1 is here. R1 can communicate across its directly connected links, but it does not have routes to the loopback networks configured on the other routers. So R1 can reach this network. So dot 2 is configured here. Similarly, dot 2 is configured here. So it can reach, R1 can reach R3's Ethernet 0/0, which is 10.13.13.2, but it cannot reach the loopback interface, which is the other end of the network, 3.3.3. Similarly, it can reach Ethernet 1/0, this interface, but it cannot reach the loopback interface. It's the same for all other routers. R4 can reach R6 Ethernet 1/2, but cannot reach the loopback address. Loopback address is basically the remote address. So from R1's perspective, if you even talk about 10.24.24 network, this is the other end of the network, so it does not have routing information to reach that network. So R1 cannot talk to any of these network, or even if R1 wants to reach the loopback of R6, it does not have the routing information. So our objective in this lab is to configure EIGRP on all 7 routers so that they can form neighbor adjacency, exchange routing information. So that is our main goal, and learn those remote networks. So once the configuration is completed, we will verify the EIGRP neighbor table and confirm that the expected neighbors have been established. We will then check the EIGRP topology table to confirm that routing information has been learned. We will also examine the IP routing table and verify that EIGRP learned routes are present, basically installed in the RIB. Finally, we will test end-to-end connectivity. For example, R1 should be able to reach any of the loopback address, this one, or R4's loopback, or R7's loopback. Before we begin the configuration, I would do a quick recap of the basic EIGRP configuration. This is our task list, which we were discussing in the whiteboard, and this is our lab topology. So let's do a quick recap first. EIGRP configuration. So EIGRP can be configured using 2 methods. I would say before even we get into the configuration, let's get into the basic facts, some information about EIGRP. Although we covered this in the theory class, let's do a quick recap before we even create the configuration template or we start the lab, right? So I will start with protocol overview. We'll move this here. So EIGRP was originally developed by Cisco and is now an open standard. It is a classless routing protocol, so it supports VLSM and CIDR along with both automatic and manual summarization. Let's talk about operations a bit. Let's copy this. So in terms of operation, EIGRP uses dual algorithm to calculate loop free path. These are good to know information, not something that you have to remember. And EIGRP sends hello packet to the multicast address 224.0.0.10. EIGRP sends triggered and incremental updates. So that makes it very efficient. So that's one of the main things to remember about EIGRP as compared to other protocols. So this is basically mostly our theory part. We're just doing a quick recap. I would say focus more on the theory session before you jump into the labs. So metric, EIGRP calculates its metric using k values. By default, bandwidth and delay are used. So we'll discuss metric calculation in a dedicated lab later in the series. And this is administrative distance, AD. I don't want to explain what is an AD. Uh, internal EIGRP routes have an administrative distance of 90, and external EIGRP routes have an administrative distance of 170. Covers the basic protocol overview of EIGRP. Now let's get into configuration. So as I mentioned earlier, there are two ways to configure EIGRP. The first method is classic EIGRP. The second one is named EIGRP. In this lab, we will use the classic EIGRP configuration method. We will look at named EIGRP separately in a later lab. So let's look at the syntax. So to start the EIGRP process, we use the command router EIGRP followed by the autonomous system number, AS number. In this lab, we will use AS number 100. The AS point to note, the AS number must match between directly connected routers before they can form an EIGRP neighbor relationship. So after entering EIGRP router configuration mode, we use the network statement. So it's network, the network address, and the wildcard mask. So the network statement identifies the interface that we want to participate in EIGRP. So the router compares the IP address of each interface with the network statement and wildcard mask. Any interface whose IP address matches the network statement specified here will participate in the EIGRP process. So basically the interface will begin sending and receiving EIGRP packets, and its connected network will be advertised to EIGRP neighbors. Let's take an example. I will take example of R1. So the configuration would be router EIGRP, autonomous system is 100, network, we will do 10.12.12.0, wildcard mask .3, network 10.13.13.0, wildcard mask, network 1.1.1.1, the wildcard mask, network 10.1.1. I made a mistake here. Oh, that is correct. So this is 10.1.1.0 and this is 0.0.0.255. So if you look at this example from R1, router R1, the first network statement which we have here, this matches the interface E1/0. So EIGRP process will get enabled here. The second statement matches E0/0 connecting to R3. And the third and the fourth statement match the loopback interfaces. So we'll apply similar configuration on each router based on its interface addressing, right? So let's quickly look at what happens after the configuration. So I'll take R1 as an example. A is 100 and R2. So once EIGRP has been configured on both ends of the link, the routers will begin sending EIGRP hello packets. These hello packets are sent to multicast address 224.0.0.10, which we saw in our theory section. So these hello packets are used to discover other EIGRP routers on the same link and to maintain the neighbor relationship. So what happens is R1 sends hello to 224.0.0.10 and then I'll put it this way, R2 will respond to that hello with its own hello packet to R1. So if the required EIGRP parameters match between R1 and R2, the routers form a neighbor adjacency. We can verify that relationship using EIGRP neighbor table. Remember these? There are a few things like for example the neighbor table, the topology table and the routing table. So after becoming neighbors, right, the routers exchange routing information. The learned information, the learned routing information is actually stored in something called EIGRP topology table. And the selected routes from the topology tables are then installed in the routing table. We can call it as RIB as well. So we'll see all of this during the verification section. For this lab, our main focus is to configure EIGRP correctly, bring up the expected neighbor adjacencies, and confirm that the remote networks are being learned. We will discuss the individual fields in the neighbor table and topology table in more detail in the upcoming lab. So I have an example already here. So I'll use this and let's create the template. R1 is done. I think I'm missing a network here. So I think this is to R5. So we will do 15. This statement will enable EIGRP process on this interface E0/1, which connects to R5. Now let's do R2. It has the same networks. 10, 12, 12 matches. So let's do 24. This is one of the main reasons why we create templates, because it saves a lot of time. 2.2. We are done. Let's go to R3. EIGRP 100 participates in 13 connecting to R1, 34 connecting to R4. The loopback address is 3.3.3.3 and this is 10.3.3.0. Let's quickly do R4. R4 has 24. There is one more connecting to R6, which is 46.46, and the loopback address .4 R5 just has one interface, one physical interface participating in EIGRP, and we also advertise the loopbacks. R4, R6. I will remove this. This is 67.67. This connects to 7, R7. Let's change the name to 6. And this is 6.6. And the final router, which is our R7. Oops, it has only one physical interface. 7.7.7.7, and we have 7.7. With that, we have completed the template. I think I didn't start the devices. Let me quickly boot all the devices and get the CLI sessions. I'll pause the video and resume when I have all the PuTTY sessions open. So we have CLI of all the routers opened. Let's bring them front. I wish we had secure CRT. It would have been easier to manage the session, but that's okay. So R1, we'll go to enable mode, and let's do a quick verification if we still have the interfaces. Everything looks good. We go to the conf t mode. We will take our configuration from R1 and we will paste it here. And we will exit. Let's go to R2. Interface is up. Show IP interface brief. 12.24.2.2 looks good. Conf T, paste, exit. Router R3, enable. I'm not going to verify the interfaces. They would have been configured. We see the adjacency is already up. This is between R1 and R3. We will do the verification later. Let's go to R4. Copy the config. Enable conf T, paste, exit. Wow, this was pretty fast. So we have neighborship with R2 and R3. Now let's go to R5. Enable conf T, exit. The adjacency came up immediately. R6. Enable conf T. R6 is configured. Done. Conf T, done. So with this we have added configuration to all the routers. Let's look at our task list. We have completed this. We have completed this. So it says verify that EIGRP neighbor adjacencies have been established. So maybe we'll start with R1. I'll copy this, paste it to the bottom. To verify this, we use show IP, EIGRP, and EIGHP or neighbor command. So let's copy this, enter here. So this shows us the neighborship formed on R1. So basically what you see here is the address column. This shows the address of the neighboring router. So from 10.15.15 we understand this is our R5 router from the topology. The interface column tells the local interface through which the neighbor relationship has been established. So on R1 Ethernet 0/1 I'm connecting to R5. Let's do show interface description. So Ethernet 0/1, Ethernet 0/1 linked to R5. Ethernet 0/0, here is 0/0, that is my link to R3. The whole column basically shows us the whole timer. As long as hello packets continue to be received from the neighbor, this timer is continuously getting refreshed. We will discuss hello and hold timers in more detail in a later lab, I would say. And then what else do we have? I think we have the uptime. The uptime column shows how long the neighbor relationship has been established, since how long it has been up. So we can refresh and see again. So this is 13 seconds. You see it will refresh now. It's at 11, 10. Let's wait for it refreshes. So the uptime shows R5 is up from 5 minutes 47 seconds, 6 minutes 49 seconds. So this pretty much confirms that the neighbor adjacency looks good on R1. Now let's take the same command, try it on R3 on all the routers. So we have our show interface description, Ethernet 1/1 and Ethernet 1/0, R1 and R4, which looks good. R3 looks good. We are expecting to see R4 and R1. Here we should see neighborship to R2, 102424, 103434, 104646. So 1024 is to R2, 1034 is to R3, 1046 is to R6. We see 46, 34, 24. Looks good. R5 only one neighbor to R1. Looks good. Two neighbors in R6, one to R7 and one to R4. So with this we complete our verification. We see adjacencies have been formed successfully on all routers. So this is completed. So let's go to the next task. Verify that EIGRP has learned remote networks. I feel after adjacency, let's make this change. This should come here, and maybe here we should verify if routers have if routers have exchanged routing information. This makes more sense here. Okay, so let's copy this one, right? Verify if routers have exchanged routing information. This is below this one. Verify that this looks wrong. This wasn't the task that we completed. Okay, let me correct that. So this is the okay. Verify that EIGRP neighbor adjacencies have been established. So show IP EIGRP is to verify the adjacency. This one we have completed. So verify if routers have exchanged routing information. What would we do? How would we verify? We would verify using show IP EIGRP topology command. The topology table basically contains all the routes that EIGRP has learned. So before the best routes are installed into the IP routing table, they are maintained by EIGRP in this table. So enable, did we copy this command? No. Okay, let's copy, try this on R1. Okay, so we do see routing information here. I'll try to expand this. So I entered show IP EIGRP topology. This tells me all the routes that are maintained by EIGRP. So this, the first field that you see, this is, for example, let's take this one. So this is the network prefix, it's directly connected, right? Or let's pick this one. So let 10.5.5.0/24. So this is basically a network prefix. This field identifies the destination network, which is R5's loopback that has been learned. And we are learning this via 10.15.15.2. So this is our next hop address. You'll notice several additional fields in this output, like the route state, successor information, FD, metric. There are a lot of information. You see P here, and I think we'll discuss each of this in a detail in our upcoming labs. For now, our objective of this lab is simply to verify that the topology table has been populated successfully. So let's do the same verification on R2. Let's make this smaller. Oh, it has the topology table. Let's do from R3. So from R3, let's see if R7 is available, right? So we are looking for 7.7. We see 7.7.7. The network is available. It's reachable via 10.34.34.2, which is your R4 router. So it's reaching R7's IP address, the destination network, through this next hop. So R4, we see the topology table. It's populated. R4 also looks good. R3 looks good. R5 is going to be pretty much the same. Let's verify in R6 as well. Okay. So this tells us that the routers are exchanging routing information successfully. Now let's look at what is the next task. The next is this is completed. Let's mark this as completed. Now verify that EIGRP routes are installed in routing table. This is the RIB, the IP routing table. So the command is show IP route, and we can filter EIGRP routes, but I will do show IP EIGRP. So show IP route EIGRP. This will show us only the EIGRP routes that are installed in the routing table. Let's quickly verify that in R1. So we see all these routes that are learned in the router R3. So if you look at, let me bring this here and expand. Okay, so this is a much better view, right? I'll use the command again. I entered show IP route EIGRP and I'm seeing all these routes. So if you look at the D, this indicates route learned via EIGRP. This is the destination network, and this is the destination network. For example, 4 network, I'm learning this. Here I'm learning the router R2's loopback. This is R6 loopback. This is R7 loopback. And if let's pick this 6, right? I'm learning this via this next hop, which is 10.13.13.2, which is basically our R3 router. And this is the outgoing interface. So when R1 wants to communicate with 6.6.6, it will use Ethernet 0/0 for the outgoing packets, the egress packets. You will also notice the value the value 90 here. We discussed about this. This is the default administrative distance for an internal EIGRP route. So since the remote networks are now present in the routing table with the D code, we can confirm that EIGRP has successfully installed these routes and they are now available for packet forwarding. We can also do show IP route. This will show us all the routes. This is directly connected routes. So the D's are basically our EIGRP routes. Since we are learning all the routes, let's do a quick verification. So from R1, I'm going to ping the IP address 7.7.7 and it is success. Let's try to ping 6.6.6.6. It is successful. We can try this from R5 as well. From R5, let's bring the routing table. I did show IP route. I'm not filtering EIGRP. We see all the routes here. So these are the local routes, directly connected routes, and the D indicates the EIGRP routes. It is learning since R5 has only one interface connecting to R1, and that is the only entry point for all the routes to enter R5. We are pretty much learning all the remote networks from Ethernet 0/1 from our topology, which basically connects to R1. We will see a similar kind of a routing table in R7 as well. So let's try to ping the remote network of R6 from R5. It is reachable. We can try pinging any of the directly connected networks also. So here the main things what we have to look at, observe is route has D, that means it's learning from EIGRP. This is the 90, tells us the administrative distance. This is internal EIGRP route. It is learning via 10.15.15.1 next hop, and this is the outgoing interface. And this tells us since for how long I think the route got in, since how long the route got installed in the routing table. It's up from 39 minutes 30 seconds, which we can also compare with neighbor table, right? It's up from 41 minutes, so pretty much. Let's look at the route also, up from 41 minutes. So our task, I think, completed. Verify has remote networks. Verify the EIGRP process configuration using verification commands. This is not required. I think we have completed. We are done. So this completes lab 2 on basic EIGRP configuration. So in this lab, we configured classic EIGRP using Autonomous System 100, advertised the required networks, verified that network adjacencies were established, confirmed that EIGRP learned the remote networks, verified that the routes were installed in the IP routing table, and we successfully validated end-to-end connectivity between the remote loopback interfaces. In the next lab, we'll continue building on this foundation as we explore additional EIGRP features and verification commands. Thank you for watching, and I'll see you guys in the next lab. Bye.